Good morning to all the participants. Myself, R.K. Muthuraman, Head of Aerospace Engineering, Periyar Maniammai Science and Technology, Vallam, Thanjavur. It gives me immense pleasure in welcoming you all to this online webinar series. We are conducting so many webinars during this COVID-19 pandemic. Our institution gave us permission to continue this webinar. I thank PMIST management for their approval to conduct this series of webinars during this COVID-19 pandemic so that we can't stop our learning. Today we have one such webinar, Emerging Trends in Aerospace Engineering during this recent pandemic. This webinar is going to be delivered by Dr. S.Thanigaiarasu sir, who is a Head of Aerospace Engineering in Madras Institute of Technology, Chennai. He will deliver about this particular topic. I request Shivpriya ma'am, who is a faculty of our department and also coordinator of this event, to introduce the chief guest and start the event. I once again welcome you all. I also welcome Dr. S.Thanigaiarasu sir for this webinar, and I thank you sir for your consent to deliver this lecture. Thank you sir. Shivpriya ma'am, please you can proceed with your introductory note. Thank you.
Good morning, sir. Good morning, everyone. Before starting the session, introducing the guest is a great privilege on behalf of Periyar Maniammai Institute of Science and Technology, deemed to be University Thanjavur, and Department of Aerospace Engineering. It is our great pleasure to introduce Dr. S.Thanigaiarasu sir, Professor and Head of Aerospace Engineering in Madras Institute of Technology campus and also Youth Red Cross Coordinator, Anna University, Chennai. Before knowing his achievements and awards, it is mandatory to know about his stepping stones. He has completed his BSc Physics at Madras University and B.Tech Aerospace Engineering in Madras Institute of Technology campus and M.Tech in the stream of IC engines and gas turbines at IIT Madras, PhD in high-speed jets in MIT. He is having the teaching experience of around 15 years and 5 years of industrial experience in various companies like GE Aircraft Engines USA and Tata GE. And he has published more than 80 research papers in international journal and conferences. He is the peer reviewer of the highly reputed international journal. He has published 6 chapters in Springer and 1 chapter in IGA Global. He has visited as guest lecturer in various countries like Malaysia, Singapore and China. He has filed more than 6 patents. Under his guidance, around 6 scholars completed PhD and around 10 scholars currently pursuing PhD under his guidance. And he has published more than 3 books and currently writing one book called Computational Fluid Dynamics and Heat Transfer. And coming to his achievements and awards, he is the recipient of Rajiv Gandhi Endorsement Award for the 2 consecutive years, 1994 and 1995 from MIT Chennai. And he is the recipient of Six Sigma Green Belt Awardee. And he also got Best Research Paper Award in the title of Design and Development of Magnetoplasma Dynamic Thruster in International Conference from VIT Vellore during 2011. And this is the short explanation of Dr. S.Thanigaiarasu sir. Now I kindly request Dr. S.Thanigaiarasu sir to start this session.
Yeah. So can you see this PowerPoint slide? Are you able to see the PowerPoint slide? Are you able to see the PowerPoint slide?
Yes, sir. Yes, sir.
Yeah. Okay, so my topic in this talk is on challenges in aerospace engineering during this recent pandemic. I am Professor S.Thanigaiarasu, as already introduced, and I'll be just starting with the Wright brothers achievement, that is. And in 1903, as you all know that you are all aerospace engineers, you all know that Wright brothers demonstrated the powered flight, in 1903. And before 1903, the forefathers, they felt that it was not possible to fly in the air, and anything heavier than air, it was not possible. So that is what they tried, but they couldn't succeed. But it is a breakthrough in 1903 when the Wright brothers demonstrated to the entire world that we could stay in the air for quite some time, and then in fact with the powered flight. So the powered flight, the engine they used was the piston engine, and the material they used was almost most of the structures, the wood, they used wood, and then for construction of the fuselage and other things, they used some kind of membranes to kind of stress to construct the aircraft. It was a simple construction. That is what I just wanted to tell you. In the first slide, purposely I've shown you because this gives all the information or the evolution of the aircraft that has taken place in the past 117 years approximately. And now we are talking about, in the case of propulsion and aerodynamics and structures, a lot of developments have taken place. And in the case of propulsion, and the Wright brothers started the demonstration, the power flight, they used the piston engine and water-cooled piston engine. And they stayed there for only few minutes, and the speed they could achieve was just 30 miles per hour. So very less speed they could achieve. But similarly, in the aerodynamic structural point of view, they didn't have much idea on how to minimize the drag and maximize the lift and all. So somehow they demonstrated, and then that becomes a breakthrough. And after that, people thought that, it is possible to stay in the air for some time, and it is possible to fly in the air for some time and for some distance. So based on this positive image, based on this positive thought, the people started working on this, and sometimes even during the Second World War, they started using the centrifugal compressor attached, gas turbine engines and all. And they successfully demonstrated the gas turbine engine, the flight with the gas turbine engine. So now we are talking about turbofan engine, high bypass turbofan engine. And we are also working on the scramjet supersonic combustion ramjet engine. And we use rocket engines for thrusters. We use rocket engines for thrusters, even for placing the satellite in orbit. And then, use the electric thrusters are also we are using. Such a development has taken place in the aviation field. And in the case of structures, we are now using from wood, where the Wright brothers used for their aircraft. Now we are using the nano composite and MMC nano composite, which gives a very high strength to weight ratio. So which is very important for the aerospace application. And also in the case of aerodynamics point of view, actually a lot of developments have taken place. They have started using winglets, to just reduce the induced drag form. The wings are finite, and it will the induced drag would be reduced. That will help the fuel consumption, and then it will increase the endurance. So these kind of things are taking place because we thought that it was possible to find or achieve in the field of air and propulsion, aerodynamics, and the structures. It is possible. Since we thought that it is possible, we were able to achieve up to this stage. The advanced aircraft, that Boeing, Dreamliner, and Airbus A350 and 90 and all. If you see the specifications, I've already mentioned the specifications of the aircraft used by the Wright flyers. That is, the engine was made with aluminum and 8% copper, 92% aluminum. Wood was used completely for the airframes. And as I already told you, power plant is a reciprocating piston engine, of course, gasoline engine. and they could fly only for 30 miles per hour, and the range is less than half a meter, half a kilometer, that is 300 meters are there, they could achieve, okay. And if you see the last one, okay, the point I'm trying to stress upon is that I'll tell you at the end of this discussion. If you see the now the latest transport aircraft, okay, the Dreamliner or the Airbus A350, they are now using high bypass turbofan engines. Okay, so the turbofan engine, you all know that bypass ratio, or the engine having bypass ratio plays an important role in, okay, the many factors like fuel consumptions, and even going for high amount of thrust, because it produces both hot thrust and cold thrust and all. So it is apt for transport aircraft. You can see that the maximum speed achieved is 587, around 600 miles per hour, and means it is around, okay, in kilometer, around more than 800 kilometer per hour. The range we could achieve, the maximum now, the range we could achieve is around 1,000 miles. You can think, you can even compare what we are now and in 1903, what they have demonstrated. So friends, whatever I have discussed, these slides indicates whatever I have discussed. And the point I'm trying to tell is that before 1903, people thought that it was not possible, okay, to stay in the air, it was not possible to fly. So nothing worked out. And after 1903, the Wright brothers demonstrated, okay, that it was possible. So they demonstrated, and since by seeing this Wright brothers achievement, people started working on this aerodynamics point of view, propulsion point of view, and then structural point of view, and they could achieve. Okay, they end up with the composite materials in structures, and then they end up with the high bypass turbofan engines, okay, which is apt for transport aircraft. And then in aerodynamics, they started using the winglets and all to reduce the drag and then increase the lift. Okay, and so these are all the developments that took place in the aviation field or aerospace engineering for the past 117 years. What this indicates is that as far as aerospace engineering is concerned, everything is a challenge, because many things are now unexplored. Whatever you do, whatever you invent for reducing the drag or increasing the lift, and whatever you invent for increasing the thrust, for example, thrust augmentation techniques we have in even turbofan engines, afterburner techniques you have. So whatever you invent, it will definitely add, okay, weightage to the aircraft, so that we can go for longer distance and we can fly at a high speed. Okay, so these developments are possible because we thought that we can do it. And you can, I'll show one the video that will show you how confident they are. Okay, they were in those days in 1903. How confident they were in, they were committed, and they are just in the flight. One person is moving to another flight in flight itself. So it is really a challenging one. So you just watch this, and then we will discuss what is the outcome of these inventions. And then we'll go for the impact on the education and then industries and then the job opportunities and all. This is just a kind of introduction. I would like to show this slide. Please watch. So one lady is just climbing over the wing, and then two aircrafts are above this the one aircraft, and that lady is trying to catch hold of the wing, and the struts are attached, and she is holding the strut and trying to go to the other aircraft. And again she is moving in the forward wing, with the help of the struts and this one, membranes, trying to climb down to the landing gear attachments, and she's now attaching the wheels to the landing gear. So these things, everything they are doing in flight those days. So such a confident they have, okay, they are committed, okay, to do some kind of things in the case of this aviation. So so what these slides, okay, you can infer from these slides is that it is possible. So if you think that it is possible, definitely you can do miracles. If you think that if it is not possible, then obviously you can't do anything. So that is the case. It is possible. If it is possible, okay, to go for a scramjet engine for hypersonic speed, you know what is scramjet engine, supersonic combustion, okay, ramjet engine. So that is also a challenge, okay. In the going for a supersonic combustion is also a challenge. Now we are working on the supersonic combustion scramjet engine. And then in the structures, we go for MMC nano composite. And then we design aerodynamic dynamically efficient, okay, design. The aerospace engineering itself is a challenging career, and it's a challenging study, and many things are unexplored. And if you think that it is a challenge, and if you think that it is possible to overcome the challenge, definitely you can overcome the challenge. Similarly, this recent pandemic is posing a lot of threat to the human life, and a lot of people are getting infected, and then a lot of death rates are getting increased all over the world, and even the developed countries are really suffering. So this is not the first time we are facing this kind of pandemic, and you can see in 1918 there is one pandemic which in fact devastated the entire world in 1918, that is called Spanish flu, influenza. So that actually almost took away the 1/3 of population, and maybe the similar kind of situation was there. I could see from the literatures and all. So after our forefathers, passed through this kind of pandemic, and of course after that we came across so many disasters like tsunami and even heavy rains and earthquakes. So that means the nature would give you as and when it thinks, it would give you some kind of disturbance, and but it is up to us to face the challenges. It is up to us to pass through the pandemics or the challenges we face in our life. So, like this, as our forefathers have passed through this pandemic that occurred in 1918. So we should think that it is also possible that we can pass through this pandemic, the recent pandemic, that is COVID-19. So now, giving this kind of a positive impact that we can overcome, we can also overcome this pandemic. Now let me briefly discuss on the impact of this pandemic on the aerospace engineering. So basically this impact, since we are all academicians, we focus mainly on the teaching learning process and the abroad, how it affects the students in going abroad, and then the job opportunities. So let me take first the teaching learning process. It is really completely disturbed because of this pandemic, because we all know very well that the efficient teaching learning process is a classroom direct learning process, where the instructors would stand in front of the students, and then they can share directly the knowledge, so that there will be a kind of efficient knowledge sharing is there in the direct teaching learning process. This is well proven. Okay, almost it is all over the world. It is the proven thing that it is efficient. Direct learning process is very much efficient. But of course, during this period for the past 3 or 4 months, we are not able to even sit directly and share the knowledge. Yes, of course, the alternate measure or alternate means for the direct learning system is the online learning systems or the distance learning systems. But the distance learning system, of course, the pandemic is going to be there for us for a longer period. We should go for distance learning system, whether it is efficient or it is not efficient. We should try to make this distance learning process as efficient as this direct learning process. So how it is going to be efficient? How we can make this online even learning process efficient? We are going to discuss in the next slide. But the thing is that the online learning process, okay, there is a gap between direct learning process and the online learning process. And of course, some of the universities in the abroad universities, they use some the systems like MOOC and Spook, and the resources available in online. And they already, before this pandemic, they started adopting this distance learning systems, and that is online learning systems, where the students can take up the subjects through online. They need not go to the college or the universities. And before this pandemic, it was happening, but it was around some of the universities they followed for about 9 to 10% of the academic load they shared through online. But now it has become mandatory that we should go for a major portion of this academic burden should be shared by these online systems. Okay, so how to go for these online systems, or how to make these online learning systems effective? So for the past 4 or 3 months, we are students are staying at home, and even the instructors are staying at home, professors are staying at home, and some of this, even in India, schools are started adopting these online systems, and it is going on with a full swing. But the thing is that when you go for online system, it is mandatory that the students who are staying even in the remote village, this I have already stressed upon in some of the talk I gave in 1 month back. So the students who are staying in the remote places, or whether they should get a proper infrastructure, they should get uninterrupted kind of network, and they should get a powerful laptop or high-end laptop or a very good Android one, so that they can use the facilities. Otherwise, the online systems would not be effective, because even now in the beginning itself, I faced some kind of disturbance. I could not come to online sharply at 11 o'clock because of some kind of. So these things we should take care of, so that we can go in pair with this direct teaching learning system. Obviously, we can go very near to the teaching learning system. So, my friends, it is the point I would like to stress upon here is that the pandemic is going to be there for a longer period. Definitely, we should go for. We have to share a large portion of the academic schedule. Even, of course, 100% we can say of the academic curriculum and the syllabus, everything should be shared through online. The examination also should be conducted through online, and even online examinations and even online admissions, all those things should be implemented through online, so that the academic process would not be disturbed. But at this point, I would like to advise the students who are watching this lecture is that the point I have mentioned in this slide is that usage of online and online learning systems and all, it is up to the universities to decide. They know when to use this and all. They can implement. You need not worry about that. But the point I would like to stress upon here is that those who are staying at home, they should utilize the time usefully, so that they should not lag in their knowledge when they, maybe after this pandemic, when they appear for some kind of company, or when they go for abroad studies, and when they appear for the interviews, they should not lag in their knowledge, because obviously if you don't read the books, you will not get updated. What is happening, you will not understand the physics, or you will not understand the concepts of the content of the book. So that is one thing. So if you are able to utilize the time usefully, I think you need not worry about at last the quality matters. At last, what you know in the subject matters a lot. So with this knowledge, you can even go for a company, and even the industries, they are even now, if you are something extraordinary, the industry won't miss you, even at any situation. The industries won't. The industries would try to utilize your expertise, so that the industries would grow, and even nations would try to utilize the expertise. Then a nation would really make use of your expertise. Would be ready to make use of your expertise. So you have to get equipped with the knowledge. That is very important during this pandemic period. This is a very important point I would like to tell. Other thing is that if you take the aerospace engineering field, you can see that so small projects you can do when you are staying at home. So for example, water flow channel, you can even develop with the tap available in your house, with the help of the tap itself, with which you can use this as a storage tank, and then take a channel and then put some kind of model, put some dye, so that you can visualize the different models. You can, how the laminar flow is taking place, what kind of Reynolds number, you can measure what kind of Reynolds number at which, at a different speed. And you can correlate the Reynolds number and the flow pattern, streamline pattern and all. So these things, if you are involved in this kind of activities, obviously this is not going to be a big hurdle for us. This pandemic is not going to be a big hurdle for us, because otherwise, if you just keep yourself idle, obviously it will deteriorate your knowledge as well as your thinking. And the other major thrust area nowadays, people are talking about the drones. Okay, you know, the next slide you might have seen that recently, if you just Google a boy in India, I think he is from Karnataka, who is 22 years old. He was able to design and develop 600 drones. Of course, he started developing drones with scrap materials. So you please understand. And of course, if I just went through his background, maybe he's a poor guy, and he's also he's not having aeronautical engineering degree. He's not. He might not have properly studied aerodynamics. He might not have studied the propulsion, and he may not be having much knowledge as you and me have about the structures, composites, and other things. So even then, since he is committed, I think now he has developed to a state that the country has recognized him. Okay, I think his name is, please Google through this, the boy is from Karnataka. Yes, I think he is Mysore. So he is able to develop 600 drones. You think the guy who is not having aeronautical engineering degree, he is committed, and he wanted to achieve something, and he wanted to give something to the nation. He wanted to prove himself. So he has proven, and he is able to now, okay, go to many countries. I have seen his profile and all. So this is a positive image, or the positive impression I would like to give you is that don't waste your stay time at your home. You try to utilize the time so that you can fill the gap between the direct learning system and the online learning. So if at all it is adopted. This is a message I would like to give you at this point. So the conclusion or the observation of the previous discussion is that the magnitude of the hurdle is decided by the individual. The hurdle magnitude, for me, it may be a Himalayan mountain size hurdle, I may be thinking. But for you may be thinking that the hurdle is a very kind of stone size. So what you think is what you are. So if you think that the hurdle is very small, you can pass through the hurdle. Even the simple Himalayan mountain hurdle would become a kind of stone. Otherwise, even a stone would look like a Himalayan mountain. So it is it is up to you. What is that magnitude of the hurdle and what is that you want to be, you are going to decide. So this slide tells you that if the pandemic is going to be there for, obviously, we should go for some kind of complete online classes. Accordingly, I think the syllabi and curriculum should be changed, because we are also having practicals in the conventional curriculum. We have practicals and all. Practicals means we should go directly to the laboratory and we should conduct the experiment. So if the pandemic is going to be there for a longer period, and of course, another point I would like to stress upon here is that the pandemic is not going to be, this is not the final pandemic we may be facing. We do not know what kind of pandemic we may face maybe in future, what kind of pandemic our future generation will be facing. So it is our duty to guide our future generation, how we should be acting during the pandemic, how we should face the pandemic. So these kind of messages we should record so that the future generations, our future generation, would make use of the literatures or the experience we share to them. It would be useful for them, to face the disturbance or the pandemic in future. So friends, what I suggest is that there are two educational systems now we can follow. One is the online learning systems and the other is direct learning systems. My suggestion is that you just try to increase the academic load towards the online learning system, so that whenever such kind of pandemic arises, switching over from direct learning system to online learning system would be easier. Otherwise, if you are having major load on the direct learning system as we have now, I think it is difficult. Immediately we will not be able to switch over to the online learning system. So my advice on this matter is that we have to have a model, that whenever this kind of pandemic is there, this model should be implemented and then it should be followed, so that there won't be any disturbance in the kind of the teaching learning process. And of course, there is a lot of talk that the abroad study is completely disturbed by the students. As far as these aerospace engineering students are concerned, they, after completing their degree, especially I'm talking in India, they go for higher studies like IITs, IIScs for M.Tech and even Anna University. They write GATE and then they go for it. Some percentage of students, they go abroad for their higher studies, doing MS, and some percentage they go for higher study for doing PhD also. Of course, going for higher studies for PhD research, doing research and all, the percentage is less. As you can see, these 4 circles. The first circle indicates, this is a survey conducted recently. I have taken this from this Google. This is a survey conducted from various regions of these different countries, Asia and Australia and South America and North America and all. The study says that most of the students, we know that they go for higher studies like MS and MS. That is the second slide. It shows that the students who have come from the abroad, after during this pandemic or off the way in this pandemic, students have come from abroad, to their native country. The survey was conducted and they gave some kind of feedback that when you want to continue your studies. So they immediately said that immediately they wanted to continue the studies. That is 2020, 40% they said that they wanted to immediately continue the studies. And of course, some later stages, the percentage of this one is willingness is reduced, and maybe in 2023 and all, only 7%. So that means right now we cannot predict, okay, since it is a pandemic, how long it is going to be there with us, the pandemic, we do not know. So these are all just the status at this stage. It would change also. And you can see this, the third slide, okay. The survey was conducted and the students were asked to, okay, the options of whether you would like to go abroad or you don't want to go abroad. So they around the equal percentage, that is 50% of the students, they said that they wanted to pursue their higher studies in abroad, and 50% they said that they don't know. So such a kind of dilemma is there in pursuing in the abroad studies. And of course, this is the percentage of whether they wanted to continue their studies. Those who have already pursued their study and came back to their native countries, they are asked whether you want to continue the studies. 42% of the students they said that they wanted to postpone their studies because they are really afraid of this kind of pandemic. That is quite natural. So such a interruption is there in pursuing the abroad studies. And also, not only the students' point of view, we should also think how the respective countries would allow their foreign students for their studies and all. They'll even change the visa processing. They will even change the visa processing, and then intake of the foreign students also they may reduce. We do not know. So we just have to wait and see how the universities, the foreign universities would see. And right now I heard that those who have come from abroad countries to their native country, they were using online systems, because foreign universities, most of the universities, they started using online, following online systems. And the students who are now staying in India, they are actually using these online systems and they continue the study. That is what I heard from some of my students. So obviously this is going to be solved if you go for a completely online system. But the problem here is that if you are completely going for online systems, and it is called virtual study, and the quality of the virtual study should be ascertained. There should be some kind of measure to ascertain the quality of the virtual study. So that risk is, there is a lot of difference between the degree you are getting directly and the degree you are getting through virtual study. There is a lot of difference. So those things should be addressed carefully so that you can overcome this kind of difficulties or the challenges. Then you go, I would like to talk about the opportunity, job opportunities, especially for aerospace engineers. So the job opportunities for aerospace engineers, you know very well that in India, some of the very good, the hardcore companies are there, like GE, Rolls-Royce. They have their base here, in Bangalore and Hyderabad and all. Rolls-Royce, Pratt & Whitney and all. So they take, though the production is now is paused for some time, stopped for some time, they still take the students, and because it is not completely stopped. So it is not going to be, it is not the end. That is what everybody thinks. It is not the end. It is going to be we are going to pass through this pandemic, and after some time everything would become normal. So immediately they cannot do everything. So they really want good engineers and scientists. And also I said good engineers and scientists. So what do you mean by good engineers and the scientists? So you should make yourself or equip yourself so that you can you can project your talents to the society so that you would be recorded badly. So you have to equip yourself with different types of skills like, for example, an important point I would like to say for my aerospace engineering students. You all know about this commercial software center. I don't want to name the commercial. I'll just name only what kind of softwares we are using, especially aerospace engineers. We use a software for thermal analysis. We use software for structural analysis, and we use software for fluid flow analysis and all. And this itself, there are two types. Okay, we can directly use what is the software available. Okay, commercial, then we can use it, and even industries are also using the same commercially available software. Most of the industries, some of the industries, they create their own code and then they use their own in-house software and all. So here you can see here, if there are two possibilities here. One thing is that if you are very much well versed with your analysis software, so any one of the softwares, for example, flow analysis or structural analysis or thermal analysis software, if you are very much thorough with this softwares, obviously the companies would really like to take you, okay, absorb you. Other part of this software, this one skill is writing codes and all. So very few people are there, even and in one company, if you say, even if you take a very big company, okay, the number of persons who are recruited for writing codes would be very, very less, but they are the highly paid scientists or engineers. So if you focus on writing codes, and if you learn writing, developing softwares and all, you need not go for searching for a job. You can even start a company, and you can give job opportunities for many youngsters. So it is one of the thrust areas I would like to give you from my experience. If you are, I also worked in both industries and academics. I know the necessity of this software. So either you try to develop your own code, okay, obviously you will, nothing would stand in front of you, and no hurdle would stand in front of you. If you are well versed with writing codes and all, if you are strong in any of the softwares available, okay, maybe commercially, because most of the companies are using the softwares. I don't want to name again, I'm telling you. So if you are equipped with these talents and the skills, you need not worry about the job opportunities. Only thing is that you have to ask yourself whether I am capable of doing something different or something extra. And if you say yes for your answer, then obviously you need not worry about that. And if you ask yourself that you are capable, if your answer is that no, I don't have any skills, I don't know subjects, then obviously you need not think about the job opportunities and all. It depends on you. It is not dependent on what kind of challenges we are facing now and what kind of pandemic we are having. It is not dependent on it is dependent on you, what kind of skill you possess. That is very important. Of course, this is not going to be there. So for longer period. So once if you utilize this period effectively, obviously you would fly with shining colors. Then, as I already told you, practicing the drone design. I already quoted an example, that boy, 22 years old boy. The design of the drone is not very much difficult, as he is not having even aeronautical engineering background. He was able to, but why can't you do that? You can also do that because you have already some knowledge on aerodynamics, you have some knowledge on structures, and even you have some knowledge on the flight dynamics, and you know what kind of motor you should use for the drones and all. If you just buy from a shop, propeller and motor and the rotors and motor, then you can easily design and develop. You can use your own available materials and you can develop. So nowadays the drone application is many now. They started using in fertilizers, spraying fertilizers in the paddy field and all. So it is become a Herculean task if you are having 100 acres of paddy field. It is very difficult manually. We cannot even manually if you spray the fertilizers. It is harmful for the person who is spraying the fertilizers and all. So the people are working on using these drones to for fertilizers spraying. Already it is in use. You can also join with us with this community. You can also develop this kind of skills, and you can also project yourself that you are capable of doing something, so that you would not face any challenges even during this kind of pandemic. And of course, as I already told you, please use this lockdown period effectively in understanding the concept. That will help you in getting a job. So I agree with you that there are some good companies out there, like as I already told you, General Electric, Rolls-Royce, and Pratt & Whitney, and they are in need of good engineers. They are in need of good the persons who can develop the softwares. These are all the thrust areas. So, friends, I would like to stress upon this point that you should equip yourself, before searching for a job. If you equip yourself, I think getting a job is not difficult for you. That is what my understanding is. Okay, and then now we have just come to the impact of this pandemic on the industries. Of course, it is difficult to completely list out what is the actual impact on the industries. But we can easily, right now it is a temporary halt is there in the industry side. Even the demands would have been reduced, and since the demands would have been reduced, the industries would be thinking of laying off some of the employees, but it would be of a very less percentage of the laying off would be there. Of course, after this pandemic, it would be regained. That is what we found. And one advantage is that we have even some countries have started using their airlines, maybe the transports, maybe from one country to other country. But with limited passengers, because they should maintain the gap between the two passengers so that the pandemic, the virus should not spread among them. So with the corrective measures, I think there won't be any kind of complete halt in the passengers aircraft. But so far, what I felt is most of the aircrafts would have been parked in the hangars without usage for more than 4 months or 5 months. So that really poses a major challenge maybe to the transport, continuation of the air transport. The reason is that any equipment or any instrument, if it is laid for for a longer period without any operating this one, I think we have to again test the performance of each and every component. For example, if you take engines now it is not it would have been there in switch off condition for more than 3 or 4 months. So the engine's performance should be tested. That means a very important point is that the time between overall is there for every engine or every aircraft, even aircraft components. So the time between overall is going to change now because of the aircrafts are parked for more than 4 months. The conditions would have changed. It is very important. It is mandatory that we should check the conditions of each and every components in the aircraft, including the engine. For example, if you take the engine components, fuel injection systems. The fuel injection systems, is there any rust formations on the pipes, even the turbine blades, and how the fuel quantities are mass flow rate of fuel we have to check, because if anything malfunctions, any one component malfunction, it is going to be a dangerous effect it would give. So, friends, it is a very big challenge because of this pandemic. We should take care of all these measures before the aircraft is getting into service, even after pandemic or during the pandemic also. So another very important point is that apart from changing the time between overall, it would reduce. The TBO would definitely reduce for any engine or aircraft because of this inert period. Because of this for 4 months inert period, the TBO definitely it would reduce, and immediately they should go for a performance, engine performance, put it in the test bed, find out how much thrust is produced for what is the mass flow rate, all those fuel consumptions. Especially we should see how much fuel is consumed. All those performance should be analyzed, and then only it should be put in service. And of course, the usual problem we face is that the corrosion. So if any two dissimilar metals are in contact through electrolyte medium, and a kind of corrosion would be there, the surface would be corroded. It's called galvanic corrosion. You may be knowing. And you know that the surface is changed. The surface type or the nature of the surface smoothness is changed. Obviously, it would affect the aerodynamic performance. The indirect point here is that not only it would affect the aerodynamic performance, it would also affect the engine performance, and it would affect the fuel flow rate. It would affect the SFC, fuel flow consumptions and all. So we have to make a corrective measure. We have to check each and every component, including bolt and nut in the aircraft. And we have to check the instruments in the aircraft, how the instruments are working. And you can see the pitot tube is a very important, simple instrument, but it is a very important instrument available in the aircraft, which you know very well that it is used to measure pitot tube, the total pressure, and the pitot static tube, it is measuring both the total pressure and static, that is dynamic pressure and all. So with this, even if you don't test, if you don't check that even the simple component, which is just a tube with some fine hole at the onto tip, and then it is in the form of L shape. You all know that it is a very simple component instrument in the aircraft. So if that is not that is malfunctioning, obviously it will give wrong data to the cockpit, and it will end up with a lot of problems. So my message is that this pandemic, obviously it poses challenge to the industries in many ways, but we have to take we have to adopt a certain model, even by the industries, so that the industries, when they face this kind of pandemic, I don't think they would be in trouble. They would easily pass through this kind of pandemic and all. So the message is that the pandemic would not know how long it would be there, and would not know whether this is the only one pandemic we would be encountering in the future. We do not know. We may even face in different forms. So we have to adopt a certain model, even by the academic institutions or by industries, so that the interruptions or the disturbance would be minimized. It's not completely we could, but it can be minimized. So, friends, the last slide we have, that is the conclusion. The conclusion of this lecture, the message I wanted to give you is that we have seen what is the impact on the industry, what is the impact on the academic side, and how we can utilize the period, the lockdown period, effectively, so that you can equip yourself, in doing some kind of small project like water flow channels and drone, and you can predict the flow patterns and all. So you can also read, plenty of materials are available in online. Even the books are available. Some of the journals, I know some of the journals are actually some of the journals, they have some catalog where free books are available in the journal sites and all. You can make use of this journal, these facilities, so that you effectively use this kind of pandemic. And my last message is that you all know the Stephen Hawking, who was not able to even speak and walk. He was having some neurological problem, but he found the black hole, and he demonstrated, he explained to the universe, community, global community, that there is one black hole in the universe, and whatever enters, including electromagnetic wave, whatever enters into the black hole, I think it would not be coming out, because it has got a strong gravitational effect or field. So this is the theory he explained to the world, and such an achievement, because even then he was not able to speak and walk. So we should learn a lot of things from Stephen Hawking. And another example I could give is that Les Brown is a famous public speaker from America. And when he was in the childhood, he was declared as educable mentally retarded person. Now he struggled a lot, to come to this stage, and he overcome all the challenges in his childhood, because publicly he was declared as educably mentally retarded person. But now he is one of the top 10 motivational speaker in USA. So if these people are achievers, and they face the challenges in their life, and challenges would be in many forms. And now we are also facing the challenge. They came to this stage, Stephen Hawking or even Les Brown, they came to this stage by overcoming the challenge. You should have a courage to overcome the challenge. You should have the positive mind to overcome the challenge. Similarly, if you have a positive mind, if you have a positive mind, if you have a courage, definitely you can overcome the pandemic we are facing now. So I think, the conclusion is that we would also pass through this pandemic, and let us be positive. Let us be positive. We will definitely overcome this pandemic. So that's all about my lecture. Thank you very much for giving me this opportunity. I think it took around 1 hour. Hello.
Thank you, sir. Hello, sir. Thank you, sir. This is a question and answer session. Hello, sir.
Yeah. What is the time? Is it 12?
Time now is 12:10, sir.
Yeah, okay, it's okay. Yeah, now if you have any questions from the discussions or general, you can ask.
Participants, kindly post your questions. Sir, I am having a question, sir.
Yeah, please.
As from your presentation, it is clearly shown that drone technologies is emerging in current situation.
Yeah.
Emerging technology, but lab facilities are very less when compared to like AD lab, propulsion lab, but for this drone lab facilities are very less. So poor students can't improve their capability and talent without this lab facility. So what is the solution for this one, sir?
Yeah, it is a good question. I already answered in my presentation. I have quoted one example. One boy was not even having an aeronautical degree, engineering degree, and he developed the drones with the scrap materials. You just Google, you would get a lot of answers. For developing drones and all, you don't need a very big laboratory sometimes. You don't need any laboratories. Only thing is that you need the rotor blades and the motor. And you can frames, you can even make use of the materials available around you, and you can even develop. The point I would like to say is that if you start developing or designing something, you will learn as a part of this, you will get some experience that will put you in different height, and you can even develop the next time better drone with higher efficient, maybe efficient drones somehow. So I think the direct answer to your question is that you don't need laboratories for developing, designing and developing a drone. It is available. Propellers are. And one more thing, it is a good question. I really feel that even propellers and motors we are getting mostly from the abroad. This one, you aeronautical engineers, not necessarily you should go. You should go for directly, assembling the components like. Rotor blade or propeller or motor and attaching the frames and all. We can do it, anybody can do it. But you aeronautical engineers should be different from others, that you should focus on how to reduce the weight of the drone so that it can travel for longer distance, for available power, battery available power, and how to increase the endurance. And you can think of as aeronautical engineers, you can think of efficient design of the rotor blades. Efficient design of the rotor blade you can think of. And if you think, even now if you are able to design a rotor blade for a drone, and if you patent it, I think you will become a master in aeronautical or aerospace engineering field. And you will be known globally. If you claim that I have a design and I have a patent for my rotor blade is able to give this much figure of merit or this much efficiency, and obviously it directly impacts on the performance of the drone. So you have to. There is a lot of difference between somebody is doing or designing and fabricating the drone, and the aeronautical engineers they design and fabricating the drone. So you have to think in your perspective. If you are very much interested in propulsion, you should try to think in propulsion point of view, like how to use the electric, whether we can use the electric motor or we can use the small gas turbine engine. You can try for using gas turbine engine, mini gas turbine engines you can use. Very few people are using a mini gas turbine engine at boats. So these possibilities are there. Not that you should focus only on buying things and then assembling. Anybody can do it. But as an aeronautical engineer, you have to have your contribution. So if you say that, sir, I have assembled, and then now, that is the first step. I agree with you. That it is the first step. But what you should do is not this. It is the first step to go for the next step. When you go for the next step, you should focus aeronautical point of view. You should focus on the aerodynamic design propeller. And you should focus on how to have a minimum weight with maximum weight. And also you should focus on how to have efficient propulsive devices. Like instead of using, as I told you, instead of using this propeller, the electric motor, you can also use gasoline engine, SA engine, small SA engine, and you can also use mini gas turbine engines. So these possibilities, a lot of you can explore these possibilities. Still, it is unexplored. I would like to tell you that in India, you can many things are unexplored as far as this aerospace engineering is concerned. You youngsters should come forward to explore the thing, and then you can put it in about our nation in a greater right. So this is the answer I would like to give. You don't need any kind of laboratories. You can, if you think you can, definitely you can.
Okay, sir. Thank you, sir. And one of our student, Khalid Khan, is asking how this pandemic affects the job in aerospace stream.
Yeah, actually, broadly, I just mentioned that, as I already told you, it will, if you ask me, as far as I am concerned, it has not affected completely. A very less percentage of that is for a short period. It has affected the job opportunities. But I already told you, to equip yourself. Okay, if you don't have any skill, because the competition should be heavy and you should compete with many people, and even industries would not be ready to take many aeronautical engineers. They would try to reduce the intake of the recruitment. For that, you should be different from others. You should equip yourself. If you say, that's what I told you, in a software side, there are two two aspects. One is that knowing the available software and utilizing it effectively for your flow analysis or structural analysis or thermal analysis, or writing code. Okay, there is a demand for the people who are writing code, and you know very well that very few people are there in those who are developing code for the software somehow. So if you are having skill to in writing code and developing, if you develop your own software and say that this is my software, I want to sell, definitely the company would really take you. Instead of even buying your software, they'll take you and then they'll ask you to develop the software. So job opportunities, even now I have confidence in me that it is not affected completely. That too, if it is affected, it would have affected only for time being, for a certain period. It would definitely regain its original normal. You need not worry about the job. So my message is that as long as you are in lockdown, you please use the time effectively. So that is the message. If you use the time effectively, you need not worry about the job. You will definitely get the job, or you can even come to a point where you can create a job for others. Okay. Yeah. So any questions? Okay.
Yes, sir.
Yeah.
Yes, sir. Hope this session. Thank you, sir. Hope this session will be useful to you all. This is the time to end this session with great thanks to Dr. S.Thanigaiarasu sir for his admirable lecture. On behalf of Periyar Maniammai Institute of Science and Technology and Department of Aerospace Engineering, now I request Mr. Pathan Khalid Khan of third year Aerospace PMIST to deliver vote of thanks. Thank you.
Yeah, so that was a wonderful session, ma'am, today what we have today. So in that regarding, I would like to thank Dr. Thanigaiarasu sir on behalf of my department and students and faculty and all the participants who present here. A hearty thank you, sir, for delivering such a pleasant and informative session to the students. Thank you so much, sir, for that. And yeah, I would like to thank our head of the department, R.K. Muthuraman sir, and also Sivapriya ma'am, a professor in an aerospace engineering from Periyar Maniammai Institute of Science and Technology, for their effort and hard work in making this event successful today. So thank you, ma'am, and thank you, sir, for your effort and hard work for making this event happen successfully. Thank you for that. And
yeah.
I also thank our PMIST management for giving such an opportunity for us to conducting these kind of webinars to the students, the nationwide. So thank you for that. And I also thank to all the participants who present here for your patience and your presence today here. So thanks a lot to all the participants who present here. Thank you for that. So please.
Yeah, I also thank the administration of this Periyar Maniammai University, and also the assistant professor, Department of Aerospace Engineering, Periyar Maniammai University, Ms. Sivapriya, for giving me this opportunity to share my views to the youngsters, especially the students. Thank you very much.
Thank you, sir. Thank you so much. That was really a wonderful session, sir, from your side. That was really very, very, very informative session to the students to come to know any facts presenting during this pandemic, especially. Thank you so much, sir, for that.
Yes, thank you. Thanks a lot.
Thank you.
Thank you.
Thank you.
I hope all the students got to know something about the aerospace engineering challenges in this pandemic period. So with this conclusion, we can wind up this session. Thank you so much.
Thank you. Thank you.